Alright, start of our new section here is dealing with rationals, and the rationals are kind of in their own little family. 1 over x will be our standard parent function, so what we're going to do is we're going to plug in -3 to +3, and all we're doing is basically taking a reciprocal. So when you plug all those values in, you just get the flipped fraction as a result. And notice when x equals 0, well, you can't divide by 0, so we don't have a value for that. So when we try to plot some of these points, -3 comma -1/3 is real close, and then -1/2, and then -1, and then same on this side we have 1 comma 1, 2 comma 1/2, and then that's a little low, 1/2 and 1/3. So what we're looking at here though is, well, not very many points to work with, and I can't do 0 comma 0 or anything in between. Well, let's try to make this a little bit easier. If I did like -1/2 and +1/2 as x values, well, if you have 1 over 1/2, 1 divided by 1/2 would just become 2, or -2, for example. So at -1/2, you're at -2. If you're at -1/3, you'd be at -3. Same with this. +1/2 would be at +2. +1/2 or 1/3 would be at +3. And what you're going to have here is a very poorly drawn attempt, but you're basically going to go straight along the axes. Tough to draw on my computer. See if I can make this a little bit easier and just show you right there how it will actually pop up. So notice you get really, really close to these x and y axes, but you never actually touch them. That's why we have these dotted lines. Those are your vertical and horizontal asymptotes like we looked at in the last section. A vertical asymptote at x equals 0, you get really close, but you can never reach there because if you plugged in x equals 0, you can't divide by 0, so nothing works there. Horizontal asymptote at y equals 0, because no matter what number you plug in, you can get close to 0, but you'll never actually touch it. So your domain and range then are real simple. It's everything but 0. -infinity to 0, and then 0 up to infinity. X and y intercepts, well, they actually don't exist because you never cross those axes. Now, once we start shifting the entire graph up, down, left, and right, yes, you could get 1 and only 1 for all of these parent functions. Okay, even or odd function, this one right here as it is odd, and it's a 1-to-1 function when you do your horizontal line test. Here's the issue. There is no special point that you begin with in this graph like we've had in all the other ones. Really, your points that you're starting with are going to be your vertical and horizontal asymptotes. And that's really the properties that we're going to look at too. It's just your vertical and horizontals and how they're going to shift and how they're going to move. And we'll see just how easy it is to graph them here on this next slide. So when you have 1 over x, for example, all I'm going to do is I'm going to graph my vertical asymptote, my horizontal asymptote, and the part that's being graphed, all I really care about is that I'm graphing in the upper right-hand corner and the bottom left-hand corner. Just get it really, really close to the asymptotes. That's all I care about you having to do with this. Just that simple. When we do this one, x minus 2, so the denominator is like on your inside, so it means you're shifting right 2, so my asymptote has to shift to the right 2, and I'm shifting up 5. So up 5, something like that. And same thing, you're going to graph your curves in the upper right quadrant 1 if you will, and quadrant 3. And just kind of get it as close as you can to the asymptotes. In this third problem, you're shifting to left 3, so this vertical asymptote now is at x equals -3, and you've not shifted up or down, so your horizontal asymptote is still the same. The difference with this one, though, is that you have a negative out in front. So instead of top right and bottom left, we have to flip those. Top left, bottom right. Like so. And this last one down here, no inside changing. All we're going to do is change the up and down. So your horizontal asymptote goes down to -4. Your vertical asymptote is still the same. And when we graph, it'll still be top right and bottom left. This 3 It's like a 3 out in front. It means that really we should be growing a lot quicker. So what that means is you should get as close as you can to your asymptotes. This is a more gradual slope. These are really, really steep. That's about all the difference that you can make. And all they would ask you to do with those is kind of comparing and contrasting what they would look like in terms of 3 over x versus 1 over x. This guy should be much steeper. There's your basics on the graphs. Have a good day.